Hello everyone. In our earlier video, we had proved that the perpendicular from the center bisects the chord. The perpendicular from the center of a circle to a chord bisects the chord. This was proved. Now what would be the converse of this theorem? If a line is drawn from the center so that the line bisects the chord, then that line would be perpendicular to the chord, right? This would be the converse of this theorem. So let me formally write down the converse. The line drawn through the center of a circle to bisect a chord. Yes, all this is given. We have started off. This is the hypothesis. The line drawn through the center of a circle to bisect the chord is perpendicular to the chord. So this is the converse of the above theorem. And now in this video, let's try to prove the converse of this theorem. Right? So how do we go about proving it? First of all, let us consider a chord AB. So AB, and draw a line from the center of the circle to the chord in such a way that it bisects the chord into two equal halves. Right? Let O is the center. Now what is given? We have already started off with AM is equal to MB. The chord is already bisected into two equal halves. What do we have to prove? That it is perpendicular. That OM is perpendicular to AB, right? This is what we'll have to prove. To prove OM is perpendicular to AB. So let's proceed. Let us connect the OA and OB. If you join OA and OB, we get two triangles. What are the triangles? Triangle OMA is one and triangle OMB is another. And what do we know about these two triangles now? The first one we know is what is given already, is what we started off with, that AM is equal to MB, right? This is given to us. And we are also, we observe that OA and OB, since it starts from O, the center, and touches the circumference of the circle, we can say that OA is equal to OB, both are equal as they are the radii of the same circle, right? And what else? We are also aware of what the third side is. OM. OM is the third side of these two triangles which we are talking about, and OM is common to both the triangles. So what do we have? We have that the corresponding sides, all three sides of these two triangles are equal to one another, and since the corresponding sides are equal, we can declare that triangle OMA is congruent to triangle OMB by the SSS axiom of congruency, the side axiom of congruency. And because they are congruent, all the other corresponding parts also are equal to one another. That is, the three angles, the three corresponding angles would be equal. And we are interested about this angle, right? OMA, angle OMA is equal to angle OMB. The reason is corresponding part of congruent triangles. They are equal to one another. But it is not enough if we say that they are equal, because we'll have to prove that they are perpendicular. This line OM is perpendicular to AB. How do we do that? If line OM is perpendicular to AB means we'll have to say that OMB and OMA are equal to, these two angles are equal to 90 degree each. So how do we do that? If you look at OMA and OMB, you can easily say that these two angles, angle OMA and angle OMB are angles in a straight line, right? Angles in a straight line. So the sum of these angles will be equal to 180 degrees, right? Observe the angles OMA, OMB. The sum of the angles, because they are angles in a straight line, the sum should be equal to 180 degrees. And we also know that they are equal to one another. The two angles are equal to one another. So angle OMA is equal to angle OMB. So you can divide 180 by 2 and say that each angle is equal to 90 degrees, right? And hence we have proved that OM is perpendicular to AB, because we have proved that the angles made by OM on this line AB is 90 degree on either sides, both sides. So OM is perpendicular to AB, and that is the converse of the above theorem. I hope you followed. Thank you.